So we're talking about combustion, chemical reactions, and we're looking at that as being a large source of energy for today's economy. We saw 83% of energy that we use comes from fossil fuel-based energy, and consequently it would involve combustion. So to begin with, let's review combustion, or take a look at what combustion is. So when we have combustion, what is happening, it's a rapid oxidation reaction, so it takes place very quickly. And in the process, it generates heat, or both light and heat. And that's why when we look at a flame, we can actually physically see it. Although as the temperature drops down higher up in the flame, you no longer are able to see it. However, it is still very, very hot. And it's still a buoyancy-driven flow. The other thing that goes on is we have a chemical reaction whereby the chemical bonds within the fuel are being converted into heat. And so it's what we would call an exothermic reaction. Now, in order to understand combustion, which is what we will be looking at here, in order to understand combustion, it requires a combined knowledge, first of all, of this course, thermodynamics. It also involves heat transfer, because as you have the heat release, heat is being transferred through the fluid and the fuel itself, and mass transfer. Mass transfer is the process by which the reactants are allowed to come into contact with one another. And so it can either be just straight diffusion, or it could be turbulent diffusion, laminar diffusion, turbulent diffusion, where the fluid flow actually provides a bit of the mixing drive for the mass transfer to take place. And so we could refer to this as being diffusion of species. And if it's just simple diffusion, then that would be, you could call it laminar mixing. And we can also have turbulent flow mixing. And when we looked at the combustion taking place within the engine that I showed you in the previous clip or segment, that was definitely turbulent combustion going on there. We had very, very large vertical structures. They were causing the oil, once it had been vaporized, to mix and react with the oxygen that would be present within the air. And the final thing that we would need to understand is what they sometimes refer to as being chemical kinetics. And that enables us to figure out how quickly the reactions are going to take place. And the reactions can get rather complex. So essentially what we're looking at is mix between thermodynamics, which we'll cover here, heat transfer and mass transfer, which could extend into fluid mechanics, and then chemical kinetics. So those are the three areas. We will primarily focus on the thermodynamic aspects, but in order to develop a full and comprehensive understanding of combustion, you really need to study all three of those simultaneously in order to make proper gains. So what we will be doing, we will be simplifying the reactions And by that, what I mean is that we usually will consider the reaction as being a single step process. So let's take one of the simplest oxidation reactions that exists, which is the oxidation of hydrogen with oxygen. And when that occurs, we get 2 moles of water. And let's assume it's water vapor, it doesn't really matter. But in reality, this is what we would study if we were taking a class in chemistry. Actually, it's what we're going to be doing here in thermodynamics because it simplifies things. But in reality, this is actually more complex. In reality, what happens is we have the H2. There are actually a number of reactions. So you start to get the picture that it gets more and more complex. We have intermediate reactions going on. And in actual fact, for a complete picture of what's going on here, of the oxidation reaction of hydrogen, we would require 20 or more separate reactions. So you can see it does start to get complex, and that gets into the chemical kinetics side. What we are going to do, we're going to stay back here with just a single step reaction. It is a simplification, however, it enables us to do our analysis and then look at the thermodynamic aspects of the heat release that is occurring with this type of reaction. And that's primarily what we'll be doing in this chapter.